Millions of people around the world rely on coral reefs for marine resources. They're important for nutrition, and they're a major protein source in especially developing island nations. The IUCN, the International Union for the Conservation of Nature, has a goal to protect 30% of all habitats in the ocean by 2030 in marine reserves.
When the centre was first established in 2005, we knew that if you set up an individual reserve, that we'd start to see a bigger sort of biomass of fish inside these protected areas. The big question that everybody wanted to know back then was, to what extent is the breeding that's going on in reserves benefiting the adjacent fisheries?
We've learnt an enormous amount about the potential for marine reserves, not just as conservation tools, but as fisheries management tools. That's been mostly due to great breakthroughs in tagging and tracking marine larvae, fish larvae. The study done in 2006 to 2009 in the Keppel Islands was a major breakthrough. They were one of the first studies in the world to show absolutely and utterly unequivocally that larvae of targeted fish went from areas closed to fishing out to areas open to fishing by larval dispersal. And they did that with genetic technique called parentage analysis.
The beauty of genetic parentage analysis is that if you can find a juvenile fish on the reef, you can sample its parents, you know exactly where it's come from and what distance, what direction. When I was growing up as a student, this was the holy grail, this was the thing that we all thought we might never know.
When Geoff Jones first showed me the initial results from the Keppel Island study, a map with lines going all over the place, that was just mind-boggling to see that sort of stuff. I never thought I'd see data like that in my lifetime. It was a major breakthrough in marine reserves being used as a fisheries management tool, not just on the Great Barrier Reef, but globally.
When we applied DNA parentage analysis to this region where we're working, we were able to show that well-managed marine protected areas like Apo Island could support or enhance fisheries. That evidence that the center helped to produce is very crucial in supporting the efforts to establish marine protected area networks in the Philippines. To this day, I still show those results to sell the idea that we should be forming marine protected area networks.
It's every manager's dream to be able to show, for example, that zoning and no-take areas benefit both the environment and the people that rely on the reef. And research coming out of the centre has helped us show exactly that. The spillover of fish from no-take zones to zones open to fishing has been amazing, not only to show that our management is effective, but also communicating the benefits of zoning to users of the marine park.
So we have green zones where fishing is prohibited. We have blue zones where fishing is the least limited, and yellow zones are really interesting because they sort of sit in this intermediate space. So fishing is not prohibited, but it is limited, and the way that happens is by limitations on the amount and the type of fishing gear that can be used. There is a reduction from fishing in the numbers of those primary targets in those yellow zones, but we still see really healthy numbers, and the biodiversity and the overall ecosystem structure is similar between the two zones. And that's important because it indicates that these effects of fishing some of those predatory fishes are not cascading down the food chain. Yellow zones do have a great capacity to support conservation goals, especially when they are located in areas with lots of green zones as well.
Ecologists are specialists in their field. They dedicate their time to really understanding how things work and how systems work. Having well-trained staff from the centre that are so accessible and embedded in our management is critical. Working with the centre allows us to harness that information and cutting-edge research so that we are at the forefront of management.